Okay, I tried to do this on paper, but it's a little much to explain on paper. So let me do this with a little video. So first thing you got to do whenever you have something like this, you want to get everything on one side. So you want to get this 0 on one side and all the other terms on the other. So I'm going to subtract 4x and add 20 to both sides. And so this side is 0. And we have less than or equal to x cubed minus 5x squared minus 4x plus 20. So we have it. We have our thing, our not thing. We have our inequality with the 0 on one side. And the reason we want to do that is because we want to look at this expression and we want to pretend that it's x cubed minus 5x squared minus 4x plus 20 equals 0. We want to pretend it's an equal 0 because we want to look for, if I graph this, where does it hit the x-axis, right? So I want to figure out where does this hit the x-axis, because that's why you have that line, right? 0, 1, 2, 3, 4 on your paper, because you want to figure out what points does it hit the x-axis, because it's going to hit it most likely 3 times. And so what this is saying right here is it's asking, when is this equation less than or equal to 0? So that's basically asking, when is it down here or on the x-axis? Okay, so if the graph goes like this, then from here to here, it's below 0, and from here to here, it's below 0. It's less than or equal to 0. Okay, so we're looking for that kind of stuff. So we need to know where it hits the x-axis so we could know what points or what areas is it below the x-axis, because that's what this means. When I got everything on one side, it's saying when is x cubed minus 5x squared minus 4x plus 20 less than or equal to 0? When is it below or on the x-axis? So in order to do that, I need to look at this and figure out, well, when does it hit the x-axis? When does it equal 0? Because I want to find these points, the zeros. And the way I do that is I want to factor, but it's a cubic. So cubics are a little harder to factor, but there is a way to do this. So the first thing we can do is we can look at what kind of roots. It's called the rational root theorem. We can divide this by like x minus 2, x minus 3, x minus 4, x minus 1, x plus 1, x plus 3. We can divide it by one of these, possibly, and get something that has a remainder of 0. So that's one way of factoring, but the only way we can know what we can divide by is we have to figure out what are the possible roots. So we look at the factors of this leading coefficient, which is just 1. Then we look at the factors of this constant at the end, which is 20. So all the factors of 20 are 1, 2, I can't divide it by 3, 4, 5, 10, and 20. Those are all the factors there. So my possible roots, right, the possibilities of where it hits the x-axis are all these numbers over all these numbers. Well, that's a 1, so that's nice, and it's positive or negative. So here's our possible roots, plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 5 over 1, right? We're just putting it over 1 because that's the only possibility on this side. Sometimes we might have a bigger number here and we'd have more possibilities. But I like that it's just a 1 because we don't have any fractions, right? We don't have any fractions. And then we have plus or minus 10 over 1 and plus or minus 20 over 1. Okay, so these are our possibilities. We really don't need the over 1, so we can really rewrite this and say the possible roots are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Those are all the possibilities. Now I can test these all out by using synthetic division. But what I like to do is I like to pick a number that I like, right? Because we can try 1, plus or minus 1. So let's try plus or minus 1. So if we do that, if I want to try positive 1, I'll put 1 here and then synthetically divide. So I look at all the coefficients here and I put them there, 1, negative 5, negative 4, and 20. And so let's bring this down. That's 1, and then multiply 1 times 1 is 1. Then add these together. So I have negative 4. So negative 4 times 1 is negative 4. This becomes negative 8. Negative 8 times 1 is negative 8. My remainder is 12. It's only a factor if it's a remainder of 0. I don't have a remainder of 0, so that didn't work. So what I like to do is I like to jump around because I really don't want to test all of these. I really don't want to test all of these. So I just use my gut feeling, and my gut feeling says, I think 5's a root. That's my gut feeling. So my gut feeling says, okay, 5 is a root. So I'm going to divide this again by 5. So get all the coefficients, 1, -5, -4, and 20. And so if I do that, I bring this down. That's 1. 5 times 1 is 5. -5 times 5 is 0. 5 times 0 is 0. -4 plus 0 is -4. 5 times -4 is -20. And ooh, look at this. I have a remainder of 0. So that means 5 is a root. And remember, a root comes from making a binomial 0. So 5 turns into x minus 5. That's what that is when I divide by 5. So that comes from the binomial x minus 5, because since 5's a root, 5 means, 5 means x equals 5. That means I hit the x-axis at 5. So x equals 5 means when I set this equal to 0, I get x equals 5, right? X minus 5 equals 0. If I add 5 to both sides, x equals 5. That's how I get my root. So it comes from the binomial x minus 5. Okay, and then when you do synthetic division, you know that this down here is my result of dividing, right? And how is that? How does that work? Well, we move backwards. We put -4. So -4 is your constant. Then the next one is your x to the first power. Well, I don't have any x to the first power. And the next one is x to the second power. So this is my constant. The one at the end is always a constant. Remember, this number is just the remainder. So this is the result of my dividing. So my constant is -4. Don't have any x to the first power. I have 1x squared. So there you go. So if I look at this, I can factor this. That's the difference of two squares. So that comes from x minus 2, x plus 2. And then, of course, I have x minus 5 because that's my other root, the one I did by dividing. And so now I can use that. When does that equal 0? Well, I can figure out, well, x equals 5. That's the first one we got. Set this one equal to 0. When is x minus 2 equal to 0? We'll add 2 to both sides. And I get x equals 2. And when is this? What's going to make that 0? So x plus 2, when is that going to be 0? Well, subtract 2 on both sides. I get x equals -2. So there are my roots. So now I can draw my number line. Here's 0, 1, 2, 3, 4. Here's 5. Here's 1, 2, 3, 4. And here's -1, -2, -3, -4, and so on. So now I know that my graph hits the x-axis at 5, at 2, and at -2. Right? So now we got to ask ourselves, we got to go back to our original equation or inequality that says, when is that equation less than or equal to 0? So when does this graph exist down here or on the x-axis and not above? So now we got to ask ourselves, does the graph do this? Does the graph do this? Or does the graph do this? Right? Is it below right here and right here? Or is it below, oops, come on. Is it below right here and right here? So we got to do some testing. We got to do some testing. So we have our inequality, x cubed minus 5x squared minus 4x plus 20. When is that less than or equal to 0? Okay, so there's our equation. So now let's pick a value that's over here. Okay, let's pick a value that's over here because we're going to test right there. So let's pick -3. So let's pick -3. So I'm going to put -3 in here for x. -3 cubed minus 5 times -3 squared minus 4 times -3 plus 20. Is that less than 0? Let's figure it out. What's -3 to the third power? Well, -3 times -3 times -3 is -27. Minus 5 times, what's -3 squared? That's 9. -4 times -3 is +12 plus 20. So let's see, -27 minus 45 plus 12 plus 20. So this is telling me negative 27 minus 45. What is that? So negative 27 minus 45 is negative 72 plus 12 plus 20. Well, negative 72 plus 12 plus 20 is negative 40. So yes, that's true. It is less than 0. So guess what? In this green area, it's less than 0. That means it's coming up. Okay, now let's test. Now let's test this middle area right here. Okay, so we know it's negative here, so we know the value of our function is negative here in the green area. Now let's look at the purple area. So let's plug in a value in the purple area. Ooh, there's a number right there that I love that I can use. There's a 0. So let's plug in 0 into this equation. Okay, so if I plug in 0, so I'm going to erase all this now. If I plug in 0 into that expression, x cubed minus 5x squared minus 4x plus 20, that's easy because if I plug in 0, that's gone. 0 cubed is 0. That's gone because 0 squared is 0. That's gone. And I'm left with 20. So guess what's happening? This area, it's positive. Okay, now let's test something in here, in between there. And I think you can guess what it's going to be, but let's see. We never know. We need to test it. Let's test a number that's in that pink area. Let's test 3. 3 is a nice number. So if I put 3 in there, I get 3 cubed minus 5 times 3 squared minus 4 times 3 plus 20. Let's see if that's positive or negative. So 3 cubed is 27 minus 5 times 3 squared is 9. Minus 4 times 3 is minus 12 plus 20. 27 minus 5 times 9 is 45 minus 12 plus 20. And if I add those together, 27 minus 45 minus 12 plus 20, I get negative 10. So this area over here is negative. So this pink area is negative. And now let's look at the last one. Let's look at beyond 5. Oops. So let's look at this area over here. Choose a different color. So let's look at this orange area over here. So let's pick a number there. What number can we pick? I don't know, 6. We'll try 6. So let's put it in there. 6 cubed minus 5 times 6 squared minus 4 times 6 plus 20. Is that going to be positive or negative? So 6 cubed is what? Well, 6 times 6 is 36. Times 6 is 216. Minus 5 times 6 squared is 36. Minus 4 times 6 is 24 plus 20. So that's 216 minus, what's 5 times 36? That's 180. Minus 24 plus 20. So if I put that in all my calculator, 216 minus 180 minus 24 plus 20, I get 32. So that's positive. And so my orange area is positive. And so if we go back to the original statement that says, when is that expression less than or equal to 0? So now we can look here, and it's less than or equal to 0 in the green part and in the pink part. So how do I say that? So let's erase this, and let's look at those areas now. Now that we've looked at all those areas, we can say from negative infinity, and we put a parentheses because you can't put a bracket around infinity, all the way to here, all the way to negative 2. And does it include negative 2? Do I put a bracket or do I put a parentheses? Well, when is it less than or equal to 0? So at negative 2, it is equal to 0. So I'm going to put a bracket because it includes it. And then I put the union sign because I have another piece. It's not here, but it is in the pink part. Okay. And it goes from 2 to 5. But does it include 2 and 5? Yes, it does. So I'm going to put a bracket. I'm going to say 2, comma, 5, another bracket, because 2 and 5 is when it equals 0. And so there you go. Hopefully that helped. Hopefully that helped. If you have any more questions, just let me know, and I can focus in on any part that you got confused.